Hi, I'm John Peltier of Peltier Technical Services. I'd like to thank Liam Bastick and everyone at Some Product for inviting me to participate in Excel Virtually Global 2021. And I'd like to thank you for viewing my presentation. And why should you watch this? Well, I've been using Excel for nearly 30 years. First as a research engineer for managing and visualizing my data. Then after starting Peltier Tech in 2004, I've been working on Excel projects, consulting and contracting for clients large and small. I've been writing tutorials on the Peltier Tech blog, covering topics such as Excel charting, programming Excel using VBA, and programming Excel charts using VBA. I've written Excel add-ins that I sell on peltiertech.com. These help you create charts, format your charts, manage your chart data, and so forth, much more easily than the regular Excel tools. And I've been doing training for all level of users on how to become better at Excel. Now, enough about me. Let's get Excel up on screen here, and I can start my show. I'll be talking about forecasting in Excel. I'll start with some simple charts using Trendlines, then performing algebraic calculations using Slope-Intercept, moving on to Excel's forecasting functions, and ending with a built-in feature that constructs a forecast sheet. Along the way, I'll probably also mention a dozen other tricks that will make you better at Excel. And by the way, this is the first session I've ever recorded by myself. If it goes well, I can add pre-recorded video to the list of training services that I provide. This is the workbook. It has a whole lot of worksheets. I will be using sheets 1, 2, and 3 for my demonstration, but the high points of each part of the analysis are also highlighted in their own sheets later, like data, table, chart, trend line, and so forth. So you can look at them and deconstruct them on your own time if you need to go back and look. My email address is here, john@peltiertech.com, my website, peltiertech.com. If you have any questions about this, you can drop me a line, say, hey, I saw you on Excel Virtually Global, and I have this question. And I answer almost every question I get, maybe not with a very detailed answer, but at least I try to answer people that have these questions. So let's go to sheet 1. What I have here is some airport passenger data. It's like monthly passengers through a certain airport. It's dates and passengers. The dates are actual dates, January 1st, 2015, February 1st, 2015, formatted like just with the month and year, but the regular dates so they can be used in calculations. And what I have is 5 years of data from January 2015, control down arrow shows the last one is December 2019. So control back up. What we'd like to do is make some analysis of this and predict it forward 2 more years. And of course, those predictions will not be accurate because of the travel restrictions caused by COVID, but we're going to ignore that and just do some forecasting. So I've started with my data here. The first thing I like to do when I get a chunk of data like this is convert it into a table. Not just a table like you already see here, but an actual capital T table, which is a special Excel data structure that has nice features, some of which I'll illustrate as we go along. How do you make a table? There's a few different ways, but my favorite is just the shortcut Control T, T for table. I hit Control T, it says, where's the data for your table? And Excel guesses what data you want to use. If you only have selected one cell, of course, Excel looks for the boundaries of the data where there's a moat of blank rows and columns surrounding it. So it found my data, it guessed that my data has headers, and I said, okay. And here's my data, my table, and it's formatted using the default table style. You can come up here and rename your table. I'll call it something like TB, it's a prefix for table, and then passengers. So TB passengers. And it's a simple enough table. What I'm going to do is make a chart of this. So I'll come up to the Insert tab, click on line chart, and just plain old 2D flat line chart without markers. And here's my passenger data. And I always drag my charts around. If you hold the Alt key while you drag it, it will line up with the cell boundaries. So here's passenger data. You see there's a nice seasonal aspect to the data where it's low in the wintertime and high in the summertime. And there's also a year-over-year increasing trend. How do we illustrate that trend? I'll select the chart, click on the little plus icon there, and I'll select the trend line. And here's my trend line, and it doesn't predict the seasonal aspect of the chart, but it does show the trend in the center line. And so if I want to actually make a prediction, what I have to do is extend my trend line. So to format my trend line, I'll select it and Control 1. Control 1 is the shortcut that brings up the formatting dialog for whatever object in Excel you've selected, whether it's parts of a chart or a shape or a worksheet range. So it's a linear trend line. That's really the only thing that's applicable here. I'm going to extend it forward by 24 periods, which is 24 months or 2 years. And you see that the linear year-over-year trend is continuing. And if you want to make any calculations using this kind of data, you need your slope and intercept. So what I'm going to do is display my equation on the chart. And let me drag it up a little bit, and we'll make it a larger font size so it's easier to read. When your eyes start getting old like mine, it's hard to see these things. And now what I'm going to do, let me move my chart over a bit, again using Alt so it stays lined up nicely with those borders. I'm going to save the slope and intercept right here in my worksheet so I can make some calculations. So my slope is 519.39, 519.39, and my intercept is 2E7, 2 times 10 to the 7th. And actually it's minus 2 times 10 to the 7th. Don't forget the minus sign. It's a huge intercept, but that's because the data goes back. The intercept is actually at 0 on the x-axis scale, and the date that is 0 is, well, the date that's 1, the first date in Excel is January 1st, 1900. So that goes back a long way. So this with that downward backward slope, it has a long way to go. And now what I'm going to do is insert a column here, and I'm going to do a little algebra here. I'm sure you remember this from your school days, mx plus b. And look at that. That's one nice thing about a table. When you add data to the right or right below the table senses that and expands to include it. So now it includes my this column. And what I'm going to do is type a formula in here. I want to do y equals mx plus b. So I'll type equals. M is the slope. So I'll select that cell. I'll hit F4 to put dollar signs and lock it in place. Times date. You see the table has structured formatting, and in brackets it says at date, which means the value of the date column in the same cell I'm at, and then plus B, where B is the intercept. Select the cell, hit F4, and now I'll hit enter. And you see, because it's a table, the formula that I enter in one cell of a column is extended to the whole column. Now, also, because the chart was using the 2 columns of the table, when I added a column, the chart is now using 3 columns. And you see the trend line that I have calculated here in column C is not very well lined up with the data. It falls far short. And why do you think that might be? Well, I'll tell you why that is. The trend line formula that we calculated doesn't have very many significant figures. It's got 5 figures for the slope, but the intercept, we've got 1 significant figure. We've got 2, and 2 times 10 to the 7th. So it's the 2 that's the only significant digit. So really what we need to do is get more, we have to tease more digits out of that formula. And the way we do that is we come over to the format trend line dialog here. We click on the 4th icon, and we need to change our category from general to scientific. And then we'll change from 2 decimal places. See, already decimal places, we've added some, and let's change that to 10. So we have a lot of digits. And so now we have 5.19387, blah, blah, blah. Let's just take that value and I'll copy that. I'll select the cell and I'll paste it in here. And I'll take the X off the end because we're already going to be multiplying by X. And then I'll hit enter. And we can change the format of that back to general. And now let's select our intercept. I'll go copy and I'll come select that cell and I'll paste it there and I'll say enter. And now we have a lot more significant digits here. And look, without changing anything, well, I did change the inputs to the formula. I didn't have to change the formula. And now you see the orange line has come up to exactly line up with the trend line that we calculated. Now, what I'm going to do, I want to extend my calculated trend line. So I'm going to unextend the trend line that I added to the chart. So instead of going forward 24 periods, I'm going to change that back to 0 periods. And let me get rid of the formula. I don't need that anymore. And then in order to extend the prediction, my orange line, what I'm going to do is take my dates here. I'm going to add 24 rows and by adding the date. So you can do that. You select the little fill handle at the bottom, and I have to drag it down from 63 down to 87, which will be 24 more months. And you see first what it adds, just counts by days. But what I'm going to do is I'm going to fill by months. And so now I have two years of data. And you see the formula that I had in the third column now extends all the way down to the bottom, because it's a column formula in a table. The other thing that's worth noting is the headers of my table have now replaced A, B, and C as the row headers of my Excel worksheet. And that happens whenever the cursor, the active cell, is within the table. If I click out, I get A, B, and C back, but here I am back there. So let's go back up to the top and look at this. We have a dashed line for the trend line, and let me make it a real dash line instead of those dots, so it might be easier to see. And the orange and the blue dash lines are right on top of each other. So this is as good as the trend line in the chart, except for one thing. Trend lines in a chart are really a pain to do, because you have to put the trend line formula, you have to make sure there's enough digits, you have to copy them, and then you have to paste them back in your sheet. And the thing is, Excel has some formulas that we can use to do that. So let me show you those formulas. I am going to just take these numbers, I'm going to copy them as values down here so we can see them as references. And let me just make them look a little different. And what I'm going to do here, instead of the typed in values that I use for slope and intercept, I'm going to calculate values for slope and intercept. So what I'm going to do is for slope, that's a simple formula. It's equals slope. And what I need to do is enter my known y's and my known x's. And my known y's are the passengers, and they're from January here. And I'll use Control-Shift down to select the whole range of passengers, and it stops when it gets to a blank cell here. And let me hit F4 just to lock that in place. And now I need my known X's, which are the dates in the same range. And so let me start from the last date, and I'll do Control-Shift up, which includes the header, and then Shift down. Those are just my dates. I'll hit F4 again. And so there's my slope. And to get my intercept, and you see it looks just like that slope, except because it's italic, we lost the digit. And for intercept, I'm going to do Control D. Something real weird is going to happen to the chart for a second, but let's just ignore it. Control D. So now it says slope, and I change slope to intercept, and I go enter. And you see now we've got exactly the same orange curve fit line that we had before. It exactly matches the trend line. And if I remove the trend line, I can just use that if I want. It's exactly the same as I got from the chart. but I let Excel calculate it. And this is good because if I modify any of the data, it will automatically update and I don't have to go copying and pasting data out of the silly chart. And you know, it is a nice fit, but again, it only goes through the center line of the data, but eventually we'll work our way around that. So now what I'm going to do, I'm going to leave this one behind because it's too cluttered up for me to continue. And I'm going to do some other work on a new sheet. This is sheet 2. It's got date and passengers already in a table, and it's got a chart already. And what I've done with the chart is I've already extended my my date out 2 years in the table. So the chart is plotting that, and it stops in December 2019 because there's no more data to plot. And you see I have the trend line here just for reference for now. I'm going to use a formula called trend. And let me type the name trend here. And the way trend works is I go equals trend. I enter my known Y's, and I'm going to click here to select passengers. And I'm going to select my known X's, which are the dates, and I'll click there. And now I want to know which new X I'm going to plot. I want to calculate a trend for, and I'll select that cell and I'll close it and I'll say enter. And I get these errors. And the reason I get these errors is I was using that whole column of passengers, and trend does not like to use, it does not react well to a blank value in the inputs. So I'm going to change passengers to that cell, Control Shift down to that cell. So there's no blanks. And I'm going to do the same for date. I'm going to start with December 19, Control Shift up this time. So I have the right values. And then what I need to do that I forgot to do as I was entering them is hit F4 so that that doesn't move as I copy the formula down, or as the formula is copied down by the table. And you see we get that same nice trend line. I didn't have to calculate my slope and intercept. The trend formula just has that built into it. The problem with the trend formula, as I showed, is if you include blanks in your data, and you might have a missing data point somewhere, it will choke the formula and you'll get nothing. So instead of trend, there's another formula that we can use. So let me clear that, and I'll change to forecast. Forecast works very similar to trends. You say equals forecast, but you enter the X value you want first, and then you enter your known Y's, and I'm going to select the whole column, including the blanks, and then I'm going to select the whole column of dates, and I'll hit close it, and I'll hit enter. And I don't get that error. It doesn't care that there's blanks. It just skips that data point. And so now I get the same nice trend with the forecast formula. And that's pretty much what I like to use, except in Excel 2016, Microsoft updated a lot of their forecast functions, a lot of other functions too, and they have something now, and it's called not forecast, but forecast dot linear. And you enter the same X, known Y's, and known X's as you did for forecast. I don't know what's different about this function, but I know they added other forecasting functions, which we'll get to in a long time. So here's my forecast, and you see the forecast is great. But now, what are we going to do about this? I'm going to make a copy of the chart as we go along, and just to show some intermediate stuff. And then we'll try to predict the seasonality here. So the first thing I'm going to do is add a column called deviation. And what that deviation is, it's going to be just passengers minus forecast. So it equals passengers minus forecast. And I'll hit enter, and here it is. And you see I have this data, and it's floating around the horizontal axis, but then it goes crazy down here. So what we need to do is change that a little bit. We don't want to measure any deviation where there's no actual passengers. That's where passengers are 0. So I'm going to put an if statement around this. I'm going to say if passengers is great, it selected the wrong thing. If passengers is greater than 0, show passengers minus forecast. Otherwise, NA open close parenthesis, close parenthesis. That gives me the pound or the hash NA error, which is not charted when it's encountered in a chart. So I'll hit enter, and I did something else wrong here. Oh, if at passengers. There we go. I got confused by a dynamic array. And so if I get rid of my other data here, and I'll move those labels to the bottom, you can see this is the deviation data that I have. And I can use that deviation data to figure out how to adjust my linear forecast to take into account the seasonality. So let's add a little bit more data to my table here. I'm going to add one for month, since the deviation is dependent on months. And for month, I'm going to say equals month of my date. And I'll say enter. And you see it goes 1 through 12, 1 through 12, January through December. And now I'm going to add a little range here for some calculations. And what I want is month here and deviation here. For month, I'm going to use a dynamic array formula. If you don't have Excel 365, you were going to have to type the numbers in by yourself. But if I do sequence 12, it's just going to give me the numbers from 1 to 12, which are the months from 1 to 12. And now deviation, I want to calculate what my average deviation is for January, my average deviation for February. And in order to do that, I'm going to use a formula called average ifs with an S at the end. And so I want to average my deviation if deviation and the condition I'm going to put is not equal to that hash n/a error. And also if my month equals this value here. And so this will give me the average for January. And when I fill that down by double clicking the fill handle, you see the average for February and March and so forth. They all come here. And some months are higher than average and some are lower than average, just like we can see in our trend line. And now we need one more formula to calculate our seasonal trend line. And let me double click that to make it wide enough to see all the letters. And I'm going to use another simple formula. I'm going to start with our forecast data, which was pretty good. And then I'm going to add the appropriate deviation for the current month. So for that, I'm going to use XLOOKUP. And if you don't have Microsoft 365, you can use index match. But I'm trying to learn all the new features as well as I can. So I'm going to look up the month value. Where am I going to look it up? I'm going to look it up in the list of months, which is partly hidden by my formula, but I know where it is. And what I need to do is hit F4 there. So it's going to do the calculation appropriately. And then I also need to return the value from the deviation column over here. You could actually use VLOOKUP if you want, but VLOOKUP is so old-fashioned. And then let me hit F4 here and close that. I'll hit enter. Now here's my seasonal prediction. And that's all going to show up on the top chart. And the problem here is we have too many things showing that are complicating matters. I'll move the deviation chart out of the way a little bit. And let's see, I don't need to show my trend line. I don't need to show the orange series, which is the forecast series. You see it highlighted over here. Let me clear that. And now, unfortunately, in Excel's palette, you see there's a darker blue and a lighter blue, and they're indistinguishable in the chart. So what I'm going to do is select this series, and I'm going to come to the format, and I'm going to just go to shape outline, which is the line of a series like that, and show you our calculated seasonal variation. And you see that's actually really an astounding fit. You can see a little bit of the blue sticking out underneath the orange, but the orange follows it very nicely. And actually, we can make that a little bit nicer. If this is a prediction, we don't need to show how well our formula predicts the past. We want to just show how it predicts the future. So what I'm going to do, it's taking the data from the seasonal column. I'm going to go from the first point down to where we have our last passenger value, actual value, and I'm just going to delete those cells. So now you see the blue passenger stops, and then the orange seasonal prediction starts. And in fact, what I probably want to do, I want them to match up there. I don't need that little gap. So the last passenger data, what I'm going to do, I'm just going to do equals and the passenger value so that those points correspond. And let's go back up to the top. You see the orange and the blue join at that point. And then I'm going to do a little fancy formatting. Again, I'll go back to Control-1, and let me move over so we can watch what I'm doing. I'm going to click on the paint can, and I'm going to format that line. I'm going to give it the same line color as the prediction, but then what I'm going to do is make a dashed line. And that looks like any predictive chart that anybody's ever done, at least any good-looking one. So that's not too bad. I mean, it's a lot of work to do all that algebra. My wife teaches 8th grade algebra, so she helps me a lot. And so, but you know, that's a great prediction. That's a great forecast model. But I'm going to move on to one more thing. It's a built-in feature of Excel. It's called a forecast sheet, and I'm just going to start on sheet 3 with just my bare data. I haven't extended it at all. It's just regular data here. On the data tab, way over here towards the right, is something called forecast sheet. It's right next to what if analysis, forecast sheet. And what that's going to do is build a forecast sheet that displays the data, and it makes a chart, and it shows Excel's forecast. And after it happens, I'll deconstruct what Excel did. And so I'll know how I could possibly do that myself if I want. So this is passengers and date. Just select one cell in there. We'll let Excel pick the whole range. I'll click on forecast sheet. See, Excel has selected the whole range it's going to use. And it gives me a little preview. And we recognize the blue line. And then the solid orange line is the forecast. And the very thin orange lines are actually upper and lower 95% confidence bands. So I can select where I want the forecast to end, and it's just automatically, I guess, based on how much of the data is used as input. 5 years, it decided it's going to forecast it 2 years, which is just what I've been doing. And then there's other options. I can choose, let's drag this up so we can see. It starts at December 1st, 2019. That's the first forecast it gives. I guess I could change that if I wanted it to overlap or if I wanted to leave a gap, but that's going to look silly. And then 95% confidence interval. You can change it up and down if you want, but that's also the default. There's another function or another input called seasonality, and the default is let Excel pick it automatically. And you can see by the grayed out value here that Excel has picked a seasonality of 12, which means 12 periods, 12 months. It's going to use that to calculate its ongoing values. There's other things that we might want. If there's any missing points in here, it will interpolate between the points that are present on either side to determine what to use for the missing value. The other option is just to use a 0, but if you use a 0, that could give you crazy results if your numbers are much higher than 0. These are around 3 million or so. Also, if you have any duplicate data, say you have 2 points for January 1st, 2019, how do you want Excel to deal with it? And you can use the average, which is a default, or you can use things like the minimum, maximum, the median, if there's enough for that, or the sum of them even. But I'm just going to use all the defaults, and I'm going to hit create. And Excel inserts this new sheet, called it sheet 5. I don't know what happened to sheet 4. And here's my chart, and we can see here's the passenger data is the blue. The orange data is the forecast data. Actually, the solid orange. It's hard to get my cursor in between there. So you know what I'm going to do? I'm going to make that chart a little bit bigger. So let's go up to the Format tab, and I'll make it 4 inches tall. I'll make it 7 inches wide. So that's a nice big chart. We can really work with that. So I'll click on the solid line, and you see it's highlighting forecast passengers. And here's my lower bound right here, this column, and here's my upper bound, this column over here. And now that's a great forecast. But you know something? We can still do more. We can make this even fancier. So what I'm going to do, I'm going to get my, let me click somewhere else and then click on that. All right, now I've selected my forecast. What I'm going to do is click on the paint can. I'm going to make that a blue dashed line, just like I did in my last chart. And here's the dash that I'm going to use. There's my blue dashed line. And now I'm going to build what's called a fan chart, which instead of showing little lines for the upper and lower bounds on the prediction. Well, actually, in fact, before I do all that, let's go down and look at the formulas for forecasts. First of all, for the last time we had an actual passenger value, that same value is copied to the forecast and the upper and lower confidence bounds. So those lines all meet at the last actual passenger data that's used in our model here. Now let's look at forecast. Remember, we were using something, it was forecast.linear. I'm going to click on this formula. You can see it up here. It's forecast.ETS. ETS stands for exponential smoothing. I don't know what the T stands for. Microsoft's documentation just says ETS is exponential smoothing, and that's fine. And again, it uses the X value you want to use. It uses the known Y's, which is B at the B2 down to B61. It uses the known X's. So just like forecast did, but now there's a couple of extra parameters here. And this is hard to read: data completion, seasonality, data completion, and aggregation. So let's click the little formula wizard button, and it says seasonality. Remember, we just let Excel pick it by itself. It turns out that if I click here, it tells me that if I use a default value of 1, seasonality is detected automatically. If I change that to 12, it'll work just the same, but we're letting Excel detect it automatically. And in fact, if we put a 0 in there, it will just do a linear trend without any seasonality. Data completion of 1 means it will interpolate to get the value where there's a missing cell. And then we don't even have an aggregation value, so I'm just going to ignore that, and I'll say okay. So there's my forecast ETS. And what do we have for lower and upper confidence bounds? What we're doing is we're taking our forecast and we're subtracting something called forecast.ets.confint, which means confidence interval. And again, we have the current X, the known Y's, the known X's, 0.95, that's our confidence interval that we selected in the dialog. And then 1 and 1, again, for selecting the seasonality automatically and interpolate any missing values. And for our upper bound, it's C62 plus forecast ETS confint. So the forecast.ets and .ets confint are new functions that were created by Excel just for this kind of analysis. They don't tell you exactly what the basis of their exponential smoothing function is, but it looks as good as my algebraic with the average by month of the deviation. So now let's go back up to the chart. I was making a fan chart. So I want to fill that region in between the two light orange lines with a light fill color. And I'll use light blue because it'll match the blue theme that my chart has. So what I need to do, I need to calculate what the height of that distance is, because that's how big of an area I need to fill. And I can actually use the lower confidence bound, because what I have to do is stack two areas on top of each other. So I'll stack a transparent one first and then a light blue one on top of that. But I need to know what the width of that band is. So I'm going to say width, and you see that the table adds a column, and I'm going to use the distance between upper and lower confidence. So it's equals this minus that, and that's fine. What I need to do, I'm going to still use the lower bound as an area chart. For my upper bound, I'm not going to use upper bound, I'm going to use the width. And I can change that series in the chart easily by just dragging that highlighted area off to the right. And you see now it's all zeros over here. And now it's as large as the confidence band was. And just for fun, I'll drag the series name over too. So that's called width. And let's now change our chart type. So what you do is you right click on that and it says change series chart type. If you only select some other part of the chart and right click, you get change chart type. And then if you want to do a combination chart like this, you have to go series by series and change everything from the combination chart Excel wants to make to the one that you want to make. But if you go right on a series, you only have to change the series that you need to change. So what I'm going to do, it lists all your series here, the name of the series, the chart type, and so forth. I'm going to change the lower confidence bound to an area chart and use the stacked area. And then I'm going to change the width, that yellow line, to another stacked area. And you see that's now stacked on top. So that sort of looks like what we want. So I'm going to hit OK. And now all we need to do is a little formatting. So let me select the bottom area here. Control 1 is up. So let me hit the paint can to format. And I'm going to give it no fill. And I'm going to give it no line. And now I'm going to select the orange fill up here, the gold fill for width. And I'm going to give it a solid fill, but I'm going to give it, yeah, that's a good shade of blue. And I'm going to say no line again. And now when I click off, there's my fan chart. We can make it look even a little nicer. I'm going to change this from forecast passengers to just forecast. And I'm going to get rid of the unneeded legend entries. So you do that by selecting the whole legend and then clicking again to select the one entry and delete. And I'll do that again here, width and delete. And might not even need the legend. A little more fixing up, Control 1, and I'll change the maximum to 5 million from 6 million. And I'll give it a better number format. We'll find number in the list here. And we'll use 0 decimal places, but we'll keep the comma separator. And that's a pretty nice chart, nice fan chart. And so that concludes my presentation. I hope you've learned something. And if you ever have need for any of my services, please feel free to contact me. I've been working with large and small clients, building workbooks, writing code to automate all kinds of aspects of their work, formatting, analysis, visualization, report generation. I do all kinds of training like this. Lately, it's all been virtual because of the pandemic, but I do like doing live in person training in front of a group. I think we get better interaction that way. Do all kinds of topics, formulas and functions, charting, data analysis tools like tables, pivot tables, Power Query, Power Pivot, and also VBA. And I have some software that I sell that will help make great charts and format them easily and so forth. Thanks for your attention, and don't be afraid to contact me also if you have questions about this. And thank you.